Good morning, everyone. I am Shed Chandra from Electronic Communication Engineering C section. My topic is that Introduction to Applied Linear Algebra Vectors. Getting to the topic, vectors. Vectors. First of all, outline notation. Vectors. A vector is a ordered list of numbers written as it is in the minus 1.1, 0.0, 3.6, minus 7.2, or minus 1.10, or minus 1.1, comma 0, comma 3.6, comma 7, minus 7.2. Numbers in the list are the elements, enters, coefficient, components. Number of elements is in the size, dimension, comma length of the vector. Vectors above has dimension 4. Its third entry is 3.6. Vector of size n is called an n-vector. Number are called scalars. Vectors via symbols. We use symbols to denote vectors. Example a comma x comma p comma b comma a. We use the symbols. Other convention g comma a bar. Ith element of n vector a is denoted aai. If a is vector above a3 is equals to 0, a3 is equals to 3.6. In a1, comma I is the index. For an n vector, index has run from I equals to 1 to I is equals to n. Warning. Some AI refers to ith vector in a list of vectors. Two vectors a and b of the same size are equal if is equals to bi for all I. We overload is equals to and we write this as a is equals to b. Block vectors. Suppose b, comma c, comma and d are vectors with sizes m, comma n, comma p. The stacked vectors are concentration of b, comma c and d is a is equals to b, c, d. Also called a block vector with block entries b, comma c, comma d. A as size m plus n plus p. A is equals to b1 comma b2 comma so on bm comma c1 comma c2 comma so on cn comma d1 comma d2 comma so on dp. 0 ones and unit vectors. N vector with all entries 0 is denoted 0n or just 0. N vectors with all entries 1 is denoted 1n or just 1. A unit vector has one and all other zeros, denoted ei, where I is entry that is 1. Unit vector of length 3. E1 is equals to 1 0 0, comma E2 is equals to 0 1 0, comma E3 is equals to 0 0 1. What is saying that n is within a 0 entry is denoted. N is with all entry 1 is denoted. A unit vector has one entry only. Denote C as where I is the entry is 1. Unit vectors of length 3. Sparsity. A vector is sparse if many of entries are 0. It is saying that if a vector has sparsity if many of its entries are 0. A vector is sparse if many of the entries are 0. Means if more entries are 0, it is called as sparse. Can be stored and manipulate efficiently on a computer. Enhanced is number of entries that are non-zero. Example 0 vectors, comma unit vectors. It is Outline. Examples. Location of displacements in 2D and 3D. Displacement it is also used in physics. Two vectors x1, x2 can be represented location or displacement 2D. It is a 2D diagram. X-axis is taken as x1, y-axis is taken as x2. The it is normal. Only x is called as displacement. It is x. It is a 2D diagram. It is used in physics in in graphs like explaining speed time graph, etc. Some displacement speed graph. It is used in some another graphs also. Displacement. More examples. Color. RGB. Quantities of n different commodities or resources. Example: bill of materials. Portfolio. Entries give shares or values or fraction held in each of n assets with negative meaning. Short position. Cash flow. Xi is payable in period I to us. Audio. Xi is the acoustic pressure at the same time I. Sample times are spaced 1 by 4400 seconds apart. Features. Xi is a value of ith feature or attributes of entity. Customer purchase. Xi is the total purchase of product I by a customer over some period. Word count. Xi appears in a document. Word count. Xi is the number of times word I appearance means number of it observes in the word count. Word count vectors. A short document. Word count vectors are used in computer-based document analysis. Each entry of the word count vectors is the number of times the associated dictionary word appears in the document. A small dictionary left and word count vector right. Word in number word 3. In above short document, it is a short document which is word count vectors are used in computer based document analysis. Each entry of the word count vector is the number of times associated dictionary word appears in the document. In small dictionary we can count vectors. How is means in top of that short document word it is repeated at that 3 times, in repeated 2 times, number 1 time, horse 0 times, the 4 times, document 2 times. Like this we can in the vector forms we can we can write. Dictionary is used in practice are much larger. Outline. Addition. Next topic is addition and scalar multiplication. In previous classes we have listened we have learned about addition and scalar multiplication. N vectors a and b can be added with sum denoted a plus b. Means a and b can be known as sum is called a plus b. To get some addition corresponding to 0, it given a vector 0 7 3 and 1 2 0. When we use sum, 0 plus 1 1, 7 plus 2 9, 3 plus 0 3. So it is result. It is sum. Subtraction is similar. Subtraction where example it is only example subtract subtraction in this plus example 1 minute in wait a second. Wait a second. Wait a second. Here in the here where it has plus, their example will take minus. You think there it is there minus, then 0 minus 1 minus 1, 7 minus 2 5. Example same 0 7 3 minus 1 2 0. Resultant will be result will be, I'll write here, place not sufficient. Here I'm writing, see here 0 minus 1 minus 1, 7 minus 2 5, 3 minus 0 3 only. This is answer. We understood. Next slide. Communicative law. Properties of vector addition. It is first of all communicative law. A plus b is equals to b plus a. Associative law. A plus associative law. A plus b plus c is equals to a plus b plus c. So we can write both as a plus b plus c also. However, same. A plus 0 is equals to 0 plus a is equals to a only. A minus a is equals to 0. These are the easy and boring to verify because childhood we have learned this. This all are we have learned at the childhood. Addition displacements. If three vectors a and b are displacements, a plus b is the sum displacement. It is a. Blue arrow mark is a, and another side little blue arrow mark is b. Yes, it is the particular hypothesis line is a plus b. Same will be there. It is known as adding displacements. Displacements is what used in physics more time. Displacements from one point to another. Displacement from point Q to point P is P minus Q. P to Q is P minus Q. Because it is going down, it is going down. In displacement, if it is going down means it is minus. So it is known as P minus Q. Displacement from one point to another. If it is going up to P plus Q. Scalar vector multiplication. Scalar beta and n vector a can be multiplied. Beta a is equals to beta alpha 1, beta a1, sorry, beta a is equals to beta a1 comma so on beta an, also denoted a beta. Example minus 2 196 is equals to minus 2 minus 18, means minus 2 is multiplied with 1, minus 2 ones minus 2, minus 2 nines 18, minus 18, minus 2 6, minus 12. It is an example from beta a, which is a upside multiplication. Next slide. Properties of scalar vector multiplication. Associative. Beta gamma into a is equals to beta gamma a. Left distributive. Beta plus gamma into a is equals to beta a plus gamma a. Right distribution. Beta of a plus b is equals to beta a plus beta b. These equations look in, but we sure you understand them perfectly because it is almost similar. If we go one single step also, it will do a total problem. So associative law, left distributive, right distributive, these are the similar vector multiplication, same as here. Properties of vector as somewhat similar will be there. Once we can see this associated to beta gamma into 1 square beta gamma A is equals to beta of gamma A, beta of gamma A. The left is to beta plus gamma into A is equals to beta plus gamma A. Right is to beta into A plus B is equals to beta A plus beta B. This is mm, linear combinations. For vectors a1 so on am and scalars b1 so on bm or beta 1 a1 plus beta m am is linear combinations of the vectors. And beta 1 so on beta m are the coefficients. A very important concept, a very simple identity for an n vector b is equals to b1 e1 plus so on bn en. These are examples of two vectors a1 and linear combination. These are the graphs, same as before we saw. Replicating a cash flow. C1 is equals to minus 1 comma 1.1 comma is a $1 loan from period 1 to 2 with 10 interest. C2 is equals to 0 comma 1 comma minus 1.1 is a $1 loan from period 2 to 3 with 10 interest. Linear combination D is equals to C1 plus 1.1 into C2 is equals to 1 comma 0 comma 1.2 is a period loan with 10% interest compound interest. We have replied two period loans from two one period loans. It is next in inner product. Inner product and dot product of n vectors. It is seen. Example. Another notation is a comma b comma a by b a into b. This is a 1 minus 1 2 2 transpose into 103 is equals to 2. After due to the multiplication problem solving, we will get minus 7. Properties of inner product a transpose b is equals to b transpose a. Gamma A transpose B is equal to gamma A transpose B. These are all general examples. We know this all. Examples: W is a weight vector. F is a featured vector. WTF is a score. P is vector of prices. Q is vector of quantities. T is total cost. Is all. The complexity. Flop count. Computer store numbers in floating point format. Basic arithmetic flow. Operation addition are called floating operation. Means addition, multiplication. These are known as basic arithmetic operations. Also are called as floating point operating or flops. This is very grossly approximated, but this can vary from 100. Currently, computers are around 1 G flop per second, 10 to the power of 9 flop per second. Complexity of vector addition inner product x plus y needs n additions, so n flops. X transpose y needs n multiplication n minus 1 is equals to the n much less than. Thank you everyone. Thank you everyone for listening uh, my presentation, for giving precious time. Thank you.